Remember, you need a colored pen, pencil, or marker. Take that out as well. And you need your calculator. Take that out as well. Something to get used to doing every day you come to class. Colored pen, pencil, or marker, calculator, regular pencil. If you do not have a colored pencil, I will loan one to you today. So good morning. Last time we were together, we had an introduction to my class. Today starts the real work. So we're jumping right in and getting going. You should have your colored pen, pencil, or marker in your hand. Your pencil should be sitting on your desk. There's no such thing as changing your answers or writing something in after I show you the answer because you think, oh, I meant to put -2, not +2. If you get something wrong, you get it wrong. It's not a big deal. Okay? This is a safe place to make mistakes. You're going to make them every single day. Get used to it, embrace it, it's how we learn. Okay? So we're going to be 100% honest when grading our work. Here we go. Number 1, what did you get? Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 confident people, 12, 13 confident people. Eric, Sebastian, and then, is it Anaya? Ania. Eric, Sebastian, Ania. Go.
27.
27.
27.
So you agree. All three of you agree? Maybe they all got it right. Let's find out. The answer is 27. Mark your answer correct or incorrect. If you made a mistake, no big deal. Write down the correct answer. We'll see if we can figure out where we went wrong. Number 2, what did we get? We'll start with, is it Kamoy? Kamoy, then Kisara, and then Kayla.
36.
Okay?
36.
So all three of you agree. The correct answer is 36. Now, those were numeric expressions. Now we have algebraic expressions. Let's see how we do. Number 3, what did you get? We'll start with Sharik, Dayanara, and then Maria.
100.
Okay. All three of you agree that it is 100, and that is the correct answer. It is 100. Number 4, what do we get? We'll start with Catalina, and then we will go to, is it Alyssa? Catalina, Alyssa, and then, I'm trying to remember, Zabari? Catalina, go.
I got 400.
400.
400.
You agree?
400.
Everybody agrees that it is 400 because it is 400. Very good. So, before we go over any of these, we total up how we're doing. So there were 4 questions. Where you wrote warm up, you're going to make a fraction bar out of 4 and put the number correct that you got. You always put the number correct up top. So if you got 3 of them correct, put a 3. If you got 4 of them correct, put a 4. Now you're going to write the percent correct. So when the denominator is 4, you should very easily be able to figure out the percent. So 3 out of 4 would be 75%, of course. Now, I'm going to open up the floor for questions. Are there questions on any of these? Questions on any of these? Okay, give me a thumbs up if you got 75% or higher. Good. Put your thumbs down. Good. Everyone, draw a line across your paper with your, you can put your pen down and pick up your pencil, draw a line across your entire paper. Today, we are going to talk about the order of operations, which you already know, but we're going to kick up the level a little bit. So after you draw a line across your paper, everyone write notes. Make sure it's clearly written because I'm going to be looking for that word. I'm literally, every day I see you, going to be looking for the words warm up. I'm going to be looking for the word notes. I'm going to be looking for classwork, and I'm going to be looking for homework. And so then you're going to write order of operations because that's today's lesson. Bless you. So, today we're going to talk about order of operations, and here is the order of operations that you should have learned last year or maybe the year before. Do not start copying. Do not copy this at all. So I'm showing you the whole thing, but now let's go one by one. You were taught to remember PEMDAS or please excuse my dear Aunt Sally. I have a poster of it right over there. But that's for everyday people. That's for your average young person. You are not an average young person. You are an extremely advanced young person. So we're going to use a slightly different system, but it's based on the same thing. Let's review what we know. You're supposed to do anything inside grouping symbols. Now, in the acronym PEMDAS, or please excuse my dear Aunt Sally, it's a letter P. The P is for parentheses, but now I'm using the word grouping symbols. Does anyone know why I'm calling it grouping symbols instead of parentheses? Brandon? Yeah, what is the other kind? Actually, you are right. A fraction bar is a grouping symbol, and you're actually going to learn that. That was a very advanced comment that he just made. So we're talking about parentheses, we're talking about brackets, and we're talking about a fraction bar. You do not have to copy this yet. Yes?
What about braces?
Braces and well, you're talking about the squiggly braces?
Yeah.
They're not really used as grouping symbols. It's a little bit different, but I'm glad you brought it up. You're going to learn about that a little later in the year. Okay? She's talking about these. Right? That's what you were talking about? Okay. Those are not really groupings. They sort of are and they're sort of not. Okay? We're going to basically talk about these for a while. So you always do what's inside grouping symbols first. Next comes exponents or powers. Then we do multiplications and divisions, and here's the key part. You must do them from left to right. So if a division comes first from left to right, for example, 8 divided by 4 times 3, you don't do multiplication first. Even though it says, please excuse my, the M comes first, it's not really first. The M and the D go together and they can switch around. So left to right is very important. In this case, you would do this first, then you would do multiplication. I want to be very clear about that. Does anyone have any questions? I keep telling you guys that this is a safe place to make mistakes. I'm going to tell you a mistake that I made. I think it was my second year teaching, or maybe my third year teaching. I was teaching this concept, and I didn't know that it was supposed to be from left to right. So I taught my students that it had to be multiplication, then division, no matter where it was. And then another teacher told me, you're telling them wrong. That's not right. And I had to go back and try to fix it, which really kind of messed up the kids a little bit because they were very confused. And so that was a mistake that I made. So I want to be very clear about this left to right thing. Any questions about it? The same is true for addition and subtraction. You do whichever one comes first from left to right. So again, if you have 19 minus 3 plus 2, you do not do the addition first, you do subtraction and then addition. But I'm going to show you in a minute that that is actually not going to apply to anybody in here. I'm going to show you why right now. Does anyone have any questions? So this is what you already knew. I told you not to copy it. Now you are going to start copying the order of operations for advanced users. Give me a thumbs up if you remember a phrase from Ms. Cooper, keep change change. Good. Thumbs up. Good. Just about everybody. Hopefully you remember what it means also. So we're going to use Ms. Cooper's rule that she taught me. That's going to be step number 1. We keep, change everything. Remember, keep, change is for subtraction. So basically what we're going to do right off the bat is get rid of all subtraction. We do not want subtraction anywhere. We want to get rid of it. So we're going to keep, change anything that needs to be done. Keep, changed. Then we're going to do everything else. So now we do grouping symbols. Okay, you guys do not have to write do operations that occur within grouping symbols. You're taking notes right now, right? How could I sum up that entire line so that I could write it more quickly? Catalina? Yeah, you can just put grouping symbols or find grouping symbols or whatever. You're taking notes right now. You have to start learning what words you can skip to make your life easier. The most important words are grouping symbols. Then we evaluate powers. Then we do multiplications and divisions from left to right, just like I explained a moment ago. And then, here's why we are doing this the advanced way. Because when we're done with all of that, the only thing left will be addition. You won't have to deal with subtraction or figuring out an order of things to do at the end. What we have done is, by doing step number 1 here, we have simplified step number 5. And even though I took 4 steps and made it into 5 steps, which you would think means it's longer and worse, it actually makes it so much smoother. Your brain is going to go ripping through these numbers and these operations more quickly because you're going to not have to struggle with the subtraction component. And you're going to be doing numbers 1 and 5 mentally in like a week. In other words, you're not going to have to write the stuff. It's just going to click for you and you're just going to know it. Okay? Does anyone have any questions on this advanced version of the order of operations? Good, so let's start putting it into practice. We are still in the notes section. I will tell you when it's a new section of the lesson. This is called example 1. So everyone write example 1. You can write EX1. EX1. And what I put in parentheses, you do not have to copy down, but you have to read. That's giving you a clue as to what we're going to be doing on this screen. Then copy part A. Examples must be copied, and there is a reason. I'm going to give you classwork in about 20 to 30 minutes, and you may not remember how to do a couple of different types of questions. The examples are there for you to refer back to. If you don't copy them down, you can't refer to them. I guarantee you're going to have to refer to the examples a bunch of times throughout this year. Pretty much every day you have me. All right, so let's go ahead and do part A. Evaluate 4x squared plus 3 when x equals 3. This is very similar to the questions that we saw during the warm-up and very similar to what we saw during the warm-up yesterday, or the last time we were together. So could someone remind us when we're asked to evaluate, what's the first thing we have to do? What's the first thing we have to do? Brian?
Substitute variables.
Good. I love the way you said that. Substitute. So we're going to take this number right here and put it in place of the x. Rewrite the whole expression. 4 times 3 squared plus 3. Now let's do the advanced order of operations. Start with number 1. Do keep, change. Where should I do it? Where should I do it? Anaya? Okay. Change it to what? Okay. You seem hesitant all of a sudden. What do you think? Jada? Yeah. There's no subtractions. It was a bit of a trick question, Anaya. I'm sorry I tricked you. There's no subtraction, so there's no keep, change, change. We skip over that and go to the next step. What's the next thing we have to do? What's next on the list? Anissa? Grouping symbols. Where do we go?
The 3 to the second power.
That's a grouping symbol? Hmm? Yeah, I'm saying I asked you what's next. You said grouping symbols, and I said good. Where is it? And you said 3 to the second power. And now I'm clarifying that that's a grouping symbol. Oh. Don't worry about it. It was a trick question. Are there any grouping symbols? No. So we skip over that and we go to the next step. So now, Anissa, what do we do next? Because that's a power. So we do 3 to the second power. Everyone in the room knows that. We don't need to actually talk about it. 3 to the second power is 9. On the next line of work, I write the value of that expression right below it. We didn't use anything else, so I'm going to bring the rest down. 4 times 9 plus 3. What must I do next? What must I do next? Shelby? I'm sorry? Multiply. Very good. 4 times 9, everyone in the room knows. 4 times 9, 36, plus 3. We don't really need any effort whatsoever. We get the value of 39. Circle your answer so that it is very easy to find. Does anyone have any questions on how we did this problem? Good. You guys are doing fairly well. Keep it up. Now let's kick up the level of complexity a little bit. More complex expression, more variables. Okay, so you copied the question. We're going to follow Brian's teachings, and we now have to substitute the values for the variables. So we're going to plug in and rewrite the expression with all numbers. So it's 3y, which is 3 times, and in this case, y is 6, minus, and now we've got x squared. X is 2, so we're going to put 2 squared. And then times 4. Does anyone have any questions so far? I'm going to do one thing to make sure that things are clear, and it is going to be a little confusing, okay? You have to be careful about powers. Because as Anissa and a couple other people pointed out, that we're going to do powers before we do pretty much everything else. And I have this subtraction sign here. It's going to get a little confusing, and you may not understand today, but as we go through the year, it'll start to make sense. But I want to put parentheses around this so that I know that this subtraction symbol is really being applied after the power is evaluated. It's a little confusing. It'll start to make sense as you do more and more questions. So now using the advanced form, we're going to do keep, change, change for everything, which means find the subtraction and basically keep the first thing, to the item to the left, change it, and then change the item after it to negative. So that's keep, change, change right there. So what you can see is whatever this is equal to, it's actually going to end up being a negative number. And that's why we set that up that way. If it's confusing to you right now, try not to worry about it. It's not going to happen that often this way. So it'll start to make sense. Okay? So now follow the sequence. We did keep, change, change. Now do grouping symbols. And in the grouping symbol is a power right here. So, I mean, it's really not going to make a difference, grouping symbols or powers, because the power is inside the grouping symbol. 2 squared is 4. So we end up with 3 times 6 plus, and now this is a 4, but it's now a negative. So I'm going to put that. So we took care of powers and grouping symbols. Now we need to do multiplication and division. All we have is multiplications. There's actually 2 of them. You are advanced users. Anytime you have a multiplication plus another multiplication, you can do both of them pretty much in the same step. You can do the one on the left, write down the value, then do the one on the right, write down the value. You don't have to keep rewriting the steps because, again, you're advanced. So 3 times 6, we know, is 18. Plus, and now we have negative 4 times 4. What do we get when we do negative 4 times 4? Let's make sure we know our integers the way we're supposed to. Anaya? Negative what? Negative 16. Very good. So this becomes negative 16. And now we just have adding. And so what's 18 plus negative 16? What's 18 plus negative 16? Zabara? 2. So we get a value of 2. Bless you. Now, if you had followed the order of operations like that poster, you still would have gotten the 2. Okay? What I'm trying to get you to do is focus back on keep, change, change, and how important it is to be able to mentally do that process to help yourself out. Okay? Questions? Yes. Yep. Wait, what do you mean? More than once? Like keep, change, and then change it back? Like that? So keep, change, keep, change. Yep. Okay, very good. Now, I want to say something here, and that was a really good question. There are some cases where keep, change is a complete waste of time. Does anyone in the room need to do keep, change for 8 minus 3? No. Because 8 minus 3, Alicia, is 5. So did you need to do keep, change? Now, if you did do keep, change, you still get the same answer. 8 plus negative 3 is 5. But did that make your life easier? No. So sometimes keep, change is a waste, and sometimes it's helpful. Your experience will tell you when to do it and when to not do it. Okay? Any questions? Good. We are still in notes, so don't draw a line across your paper, but this is something new that you will be doing every day. And it is called a checkpoint. Basically, I am stopping to see if you are starting to understand what I'm teaching. So everyone write, you can either write checkpoint number 1 or you could write CP number 1. And checkpoints, you do not have to copy the original question. Checkpoints, you may just find the answer. But checkpoints are timed. Okay? Since this is your first checkpoint, I'm going to give you 2 minutes for it. You're probably not going to need 2 minutes. But I'm going to give it to you, and if I find that everyone's done in 30 seconds, then I will stop the clock. But you need to try and finish in 2 minutes or less. Any work that you need to do, I should see on your paper. You just do not have to copy the original question. Any questions on what you're going to do? Good, go. Pencils down, pick up your colored pen. If you didn't finish the question, unfortunately it's going to be marked wrong and your job is to learn why you were having so much trouble. If you were able to finish, then your job is to mark your answer correct or incorrect and then learn why you may have gotten it wrong. So, what do we get? 1, 2, 3, 4, 5, 6 confident people, 7. Start with Alyssa, Brian, Anaya, and then Sharik. Go ahead.
4 1/2.
4 1/2.
1 1/2.
You agree with her? All three of you agree?
4.5.
4.5? Okay. Well, I can look up there and know that 4.5 and 4 1/2 are the same thing, but that's a different way to express it. Okay, so I got 4 people who think that it's 4 1/2. The correct answer is 4 1/2. Remember, you're going to make mistakes. I already know that there's a bunch of people who made mistakes. Give me a thumbs up if you got checkpoint 1 correct. Give me a thumbs up if you got it correct. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put your thumbs down. So that is less than half the class got it right. Could I have a volunteer give me the one reason why this question was harder than the other ones? What is the one reason why this question was harder, Sebastian?
Ample fractions.
Fraction. Just sum it up in one word. Fraction. So the issue is not algebra. The issue is numbers. This is something you're going to have to get past. Okay? So those of you who got it wrong, pay close attention. You're using your colored pen to redo your work. All of my 9 students who had their thumbs up, you're going to help us out. Okay? So now I need to remember who had their thumbs up. Where are my thumbs up students? Good. Shelby, what's the first thing you did? You said the magic word, substitute. So we're going to do 6 times. W is 1/2, so it's going to be 1/2 squared plus 3. Doesn't seem too complicated to me compared to a couple of the other ones we've done, but let's see how it plays out. Brian, what'd you do next?
We evaluated the powers.
Good, I love the way you said that. That was phenomenal. You evaluated the powers. Have to do this next. Here's where a bunch of you went wrong. What is 1/2 squared? What is 1/2 squared? Zavari? It's 1/4. 1/2 squared means 1/2 times 1/2, and so you get 1/4. We did not use either of these, so 6 times and then plus 3. So that's the first area where people went wrong. Is they did not know how to do 1/2 squared. 1/2 squared means 1/2 times 1/2, and it means 1/4. Very good. Now the next thing. What has to be done next? You can go ahead and volunteer. What has to be done next? Brandon? Multiply. Very good. And we actually talked about this the other day. How do I multiply these two numbers? How do I multiply them? Catalina?
You make the 6 as 6 over 1.
Mm-hmm. And then?
And then just multiply it over 1.
Good. Multiply top times top, bottom times bottom. 6 times 1 is 6. 1 times 4 is 4. So this is really 6/4. And then we didn't use this, so let me put plus 3. Now I want to take a quick side trip. Give me a thumbs up if you've ever driven in your family's car, if you've ever driven on the Sawgrass Expressway or the Florida Turnpike. Ever in your life. Good, put your thumbs down. So there are signs all over these highways that tell you how far you have to go to get to a location. Right? So if you're going to go to the BB&T Center to see a concert, you need to know the right exit to get off on the Sawgrass Expressway, and as you're driving, it will tell you how far you have to go. Do any of those signs ever say you have 6/4 of a mile to go? So 6/4 is not a big deal. 6/4 is what we got. That's a number. But the problem is that we don't, as humans, think like that. We don't think like, oh, I've got 6/4 of a day left of school. So can someone take 6/4 and put it in a more human number? In other words, if I were driving and it was 6/4, what would they have put on that sign so that it made more sense? Eric? Exactly. 6/4 is 1 1/2. So if you can start training your brain to take these complicated looking things and change them to something more human, your life gets so much easier. And so you will realize that 6/4 is really 1 1/2. And if you add 1 1/2 and 3, you get 4 1/2. Okay? So this looks hard. Some of you probably don't think it's hard, but some of you do. This should not look hard. And if you're struggling with how did I get 4 1/2 from this, well, if you think of money, if you have $1.50 and I give you $3, how much money do you have? You have $4.50. You add the 3 and the 1, that's 4, plus another 1/2. Are there any questions on how we did this checkpoint? Okay, so we had 9 people who said they got it right. Give me a thumbs up if you got the question wrong, but you found your mistake. Thumbs up if you got the question wrong, but found your mistake. Good, put your thumbs down. Let's get some brave people. Maria, you're brave. What was your mistake?
My mistake was that I converted 1/4 to 25.
25?
Yeah.
And what was it supposed to be?
It was supposed to be. I'm supposed to multiply it by 6.
Okay, but your instinct was to convert it to a decimal.
Yeah.
Well, that you still should have gotten the right answer.
No, I didn't put it in the decimal. I just put 25.
You put 25 instead of
A decimal.
0.25. Okay. But now, if you think back to the other day when we had a warm-up with a fraction in it, I told it, someone had volunteered that, I think it was this class, that they had converted everything to decimal. It might have been a different class. You don't want to convert to decimal. Not in this room. Not unless I tell you. Here's the rule. If the original question has decimals in it, then use decimals. If the original question has fractions, use fractions. Okay? You still can get the same correct answer, but your life is actually going to end up being harder by dealing with decimals. Because most people cannot mentally do 6 times 0.25. Some people can, but most people can't. But you can do 6 times 1/4 mentally. Okay? Comments or questions on how we did this? Good, we're doing well so far. Now we're going to add a little complexity to it. We're going to only deal with numeric expressions, but they're going to be a bit more complex. So we have no variables to deal with. We don't have any substituting. All we're going to do is evaluate. You see now the grouping symbols and the reason why I use that phrase instead of parentheses. Because we already see that there are parentheses and there are brackets. That's a little confusing. So let's do the order of operations in the advanced form. What's the first thing we're supposed to do? Step number 1. Kamoy. Yeah, and so we're going to immediately do keep, change here. So we have a subtraction, keep, change. And now we know that that's a negative 12. Next is powers. Anissa, where's the powers? Say it again. There are none. They're nowhere. So we skip over that, and now we do the grouping symbols. And here's where it gets a little hard, but you'll understand after we do this one question. Which grouping symbols do we do first? Jada?
The one between the brackets.
Okay. So how would we do that? If we just do what's in between the brackets, how would I do all of that?
You do the one that's in the parentheses.
Oh, okay. So I look at the brackets, and then I go deeper within the bracket, and I do what's in the parentheses. So here's how it works. You do the innermost grouping symbol first. So whichever one is all the way on the inside, that's what you do first. So we are going to do the 9 plus 5. So we're going to do this first. Also, when you use a grouping symbol, you get rid of the grouping symbols. So we're going to use that grouping symbol, and then we get rid of it. So 9 plus 5 is 14. So let's rewrite the whole thing. We've got 2 times, open bracket. We use the grouping symbol, so I don't have to write the parentheses anymore. I just write the 14. Plus negative 12. That's not really parentheses. That's just separating the plus from the negative sign. Divided by 4. What's next? Tristan?
14 plus
Good. 14 plus negative 12. So we're going to do this next grouping symbol right here. We're doing all of this. Very good. And what do we get? 14 plus negative 12. Everybody in the room should be able to tell me. 14 plus negative 12. Stephanie, I'm going to put you on the spot. What do we get? 2. Very good. And so one thing I want you to be aware of is we have a 2 next to a bracket. That's actually an operation. That means multiply. So when we rewrite all this, we have to make sure that we write 2 times the result of this, which is 2, divided by 4. Go ahead. Next step, or you had a question?
Oh yeah, next step.
Go ahead, next step. What do we do?
Next step, multiply and divide from left to right.
Good. So what am I going to do first in this case?
Multiply the 2 by 2.
2 times 2, and what do we get?
4.
4. Very good. So we get 4. 4, and most of you can do the rest mentally. 4 divided by 4, we get 1. Okay? Write your answer. Circle it clearly. Questions about that? Good. increase the level of complexity even further. This is a case where doing the keep, change at the beginning really helps a lot. So that's the first step. Keep, change, find subtraction. Keep, change. Now we know that that's a -4. Some of you might even want to do that. It's okay if you do or you don't. I'm fine with it either way. So after we do that, we need to do powers, and we've got 2 to the 5th power. Here's how I like to do things like this. I use my hands. I count how many 2's I'm doing in my head. Because we're going to do this mentally. There's 5 2's that I have to multiply. So I go 2, so do it with me. 2 times 2 is 4. So I've used 2 of them already. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Times 2 is 32. So it's an easy way to keep track of how many times you're multiplying. So we know that the value of this is 32 plus -4 divided by 4/5 plus 11. If you had had this question on your classwork or homework and I had not gone over it with you, every single person in the room would get this question wrong. Because right now, Dainara, your instincts are telling you to add 32 plus -4. Everyone in the room feels this pull to do 32 plus -4, but you're not allowed to. What do you have to do before you add them together? What do you have to do before you add them together? Tristan?
-4 divided by 4, 5.
Yeah, you have to do this. You have to do division. Not only is it division, it's division with fractions, but that doesn't matter. It's not a big deal. So we have to do division before we do anything else. But one thing you will notice is after we do that division, all we have left is a plus and a plus. So really we just have to take care of this highlighted part and then the rest is easy. So we're going to take a little side trip to do this. So we've got -4 divided by 4/5. Ms. Cooper taught you another phrase that helps you figure out how to do division with fractions. What was her magic phrase to do that? We got 1, 2, 3, 4, 5, 6 light bulbs went off. Jada? Dr. Pepper does not apply to this, but that is another one of her magic phrases that I do enjoy and love. Brandon? Keep, change, flip. In this case, it's keep the -4. What do we change the division to, Brandon? Very good. Keep, change, flip the second number like this. And what you're going to notice is this is actually a really easy division problem because it's a really easy multiplication. Anytime you have the same number on top and on the bottom, what do? Zabari? They cancel each other out. And so really this is a 1, and that's really a -1. And so in essence we have -1 times 5, and everyone in the room knows -1 times 5 is -5. So even though it looks hard, and I did do a side trip to take care of it, in the future, you should be able to just kind of rewrite it here and just kind of do a lot of it mentally. So this is 32 plus -5 plus 11. And now that you have only addition left over, you can do things in any order that you would like. Okay, that's the, where's the property? The associative property of addition, right? The associative property of addition says that you can add these 2 things first, or you can add these 2 things first if all you have is addition. So we could do 32 plus negative 5. We could do 32, I'm sorry, we could do negative 5 plus 11. Or you could use the commutative property, switch them around, and add any one you want. What should we add first? Who think, mentally, what would be the easiest thing to do first? What do you think, Kamoy?
To add 32 and 11 and then negative 5?
Yeah, that's what I would do, but I mean, you could do whatever you want. I like to add all the positives together and then take care of the negative numbers. So 32 plus 11, so in my mind, I'm going to do 32 plus 10, that's 42, plus another one, that's 43. So really, I have 43 and then take away 5. What's the final value? Anaya?
38.
38. Very good. Whoop. Excuse me. Questions about that? Okay. Checkpoint number 2. CP2. You do not have to copy the original question, although you're going to have to copy something to actually make it work. And again, I'm going to give you 2 minutes to do this question. Anyone have any concerns about what you're going to do? Go ahead and begin. Okay, I see a bunch of people still working. Give me a thumbs up if you finished the question. Okay, put your thumbs down. I'm going to give you another 30 seconds to finish up. So go ahead and finish. I'd rather people have an actual opportunity to finish. Circles. Try. All right. Now everyone's had a chance to finish. Let's see what we got. I walked around over there. I saw a bunch of people had answers. Sebastian, Shelby, Eric. Sebastian, Shelby, Eric, and then Ann. 6. Okay. 6. Eric? Oh, you said 6, Shelby. I'm sorry, I didn't hear you. What did you say? 6? Didn't finish? Okay. So we got 3 people who say 6. Anyone have a different answer? Or something else they want to put up? Brian?
Well, I think it's a decimal because the 9 before the 54 shouldn't have to be less.
Okay. It's an good instinct.
I think it's 1/6.
1/6. Okay. The correct answer is 1/6. If you got the question wrong, mark your answer wrong, write down the correct answer, and now I'm going to do a survey before I start. Give me a thumbs up if you got 6 as your answer. Thumbs up if you got 6. 1, 2, 3, 4, 5, 6, 7, 8. Put your thumbs down. All 8 of you did the entire question right except for the last step. And you're going to kick yourself for what you did. All of you who put 6, you did everything right. You got the whole thing, and you got 9 divided by 54, and you said that that's 6. So let me ask you this question. What's 54 divided by 9? Could someone raise their hand and tell me what's 54 divided by 9? Maria? 6. So if 54 divided by 9 is 6, how could 9 divided by 54 be 6? Brian, would you like to explain?
Because since the 9 goes before the 54, it has to be the opposite of 54 divided.
Yeah, it's the smaller number is first. Like he said, he had an instinct about it. He wasn't sure how to proceed. So what I did was I turned this into a fraction, 9 over 54, and then I just put it in simplest form, which is 1/6. Give me a thumbs up if you put 0.16 or 0.17 as your answer. Nobody? That's what you put?
I have the answer and then
Okay, so if you did in a calculator 9 divided by 54 because you weren't sure what to do, 9 divided by 54 is 0.16 repeating, and you could say approximately 0.17. Okay? Good. Any questions about how we did this one? Questions, concerns? Okay? I have one last example, but we're actually not going to do the whole thing. We're just going to talk about what it means. Example 3, or EX3, and as Brandon pointed out at the beginning of the lesson, a fraction bar. A fraction bar is actually a type of grouping symbol. A fraction bar is also a division symbol. So it actually has multiple meanings. So I need you to copy part A, but we're not going to actually simplify the whole thing. I'm just going to talk about what it means. When you have an expression on top, a fraction bar, and an expression on the bottom, what it is really saying is this. It is saying 5 times 3 divided by the whole bottom, 13 plus 6 squared minus 4. That's what it means. When you have brackets, you have to do what's inside the brackets first. So we're supposed to find this whole thing. Then we have to find this whole thing, and then we divide them at the end. So I would never personally rewrite this like this. I am just trying to illustrate to you what it means. Here's what I know in my head. I know that when I see a fraction bar like this, that it means simplify the whole top, simplify the whole bottom, then divide them at the end. Let me say that again. Simplify the whole top, simplify the whole bottom, then divide them at the end. So you still have to follow the order of operations, but you just do the whole top first, then you do the whole bottom, and then divide them at the end. Does anyone have any questions about that, on how a fraction bar works? And it's the same thing if there are variables involved. You would take this number, put it in here, then simplify the whole top, simplify the whole bottom, and then divide them at the end. Does anyone have any questions? Okay? No questions at all? Yes? Go. Okay. So now, we are now moving to the next section of the lesson. Everyone draw a line nice and clearly across your paper. And write classwork, or you can write a big CW. And then write workbook page 2. And just like I did the other day, I put them in descending order. So the highest number question actually comes first. Write them down in that order. You're going to do numbers 24, 22, 21, 18, 16, 12, 8, and 6. So you're going to do 8 questions. And there is a time limit. So you're going to have 15 minutes, approximately, before I start the clock. Where do you get the workbook? Let's go over that. I'm going to take a few volunteers. Jada's going to help, Ann's going to help, and Stephanie's going to help. The workbooks are all right here. You may not write in the workbook. You are going to use the workbook like a textbook. This pile is for you. This pile is for the middle row, and this pile is for this side. So if you would, take one for yourself, pass a couple over to her, pass a few over here. Take one for yourself and pass a few down this way, pass a few down that way. You can just pass a few of them so that they can pass them forward. Everyone should get a workbook. Do not write in the workbooks ever. My students who helped out, thank you very much. And now the clock is going to start. Go ahead and get started. If you have any questions about anything, you just raise your hand and I will come to you. Or if you want to quietly ask your partner next to you or behind you, you're more than welcome to consult with people. Okay, time is up. If you did not finish all of the questions for today, I don't want you to worry about it. I'll talk more about it in the future. But for today's classwork assignment, your time is up. Please take your pencil and put it down on your desk. Pick up your colored pen. For classwork, I do not take volunteers. I am going to reveal the answers a few at a time. Your job is to mark your own work honestly and fairly. If you got something right, put a C. Put a C, or some of you like to use check marks, that's fine. If you got something wrong, make sure you clearly mark it with an indication that it was wrong, and write down the correct answer. Because part of your job is to try and find where you went wrong now that you know the correct answer. So here we go. Start with number 24 and 22. 24 comes out to $30.60. If you did not put the dollar sign, I will accept your answer, but in the future, you need to be conscious of units of measurement. Number 22. You could have written it a number of different ways, but no, the student did not do the order of operations correctly. They should have done 15 squared first. And if you do it correctly, you get the value of 5. if you got part of this right and part of it wrong, you can give yourself half a point. And you would just indicate that by writing a half. You got the whole thing right, of course mark it correct. 21, the value is 9. 18, the value is 13. 16 comes out to 387. Number 12 comes out to 31. Number 8 is 1, and number 6 is 1. Before we start exploring where we went wrong or how we did, or I'm sorry, on particular questions, we want to know how we did overall. So there were 8 questions. So everyone's going to make a fraction bar with an 8 as the denominator, and you're going to count up the number you got correct. Hopefully you got 6 or more correct, but it really doesn't matter right now how many you got correct. If you only got one of them right, that's fine. What matters is, do you learn from your mistakes and do you do better next time? So again, hopefully you got 6 out of 8 or better, but if you didn't, don't stress about it. And then convert that to a percent. 6 out of 8 is the same thing as 3/4, so that's 75%. Figure out what your percent is, use your calculator. If you need to borrow your neighbor's calculator, go ahead and do that. And we can call this our baseline. This is how we're doing on this concept today. So now you're going to learn from your mistakes, and then you're going to have a homework assignment and have another chance to prove that you are understanding what you are doing. So first, let me survey the class. Give me a thumbs up if you got 75% or better. Thumbs up if you got 75% or better. 1, 2, 5, 6, 7, 8, 9. Good. Put your thumbs down. Give me a thumbs up if you were not able to finish the assignment. Good. Put your thumbs down. So that's a reason why a lot of us didn't get 75%. That's fine. Okay? Good. So now, questions. Questions on how these were done.
Number 16.
Number 16. Okay? So if everyone will look at their number 16, please. And here was the original question. You were given 5c squared minus 2c. And c is equal to 9. Was that the question you did? First thing I always make sure you did the right question. Did you do the correct question?
No.
Okay, you accidentally did a different question? Okay, that's fine. That's an honest mistake. Not a big deal. Which one did you do?
I accidentally did number 13 instead.
Okay, so the answer to number 13 was 1,870.
Oh, I got that.
Good. Good for you. Okay, but I do want to explore this question for one reason. This type of question is the real reason why I changed the order of operations. Because I want to show you what happens. What happens is students go, okay, I get it, Mr. Gallant. I put the 9 in here. So it's 5 times 9 squared minus 2 times 9. And here's what my students do. They go, okay, that's 81, so it's 5 times 81 minus, and it's 2 times 18. I'm sorry, 2 times 9. Some of my students don't carry the subtraction sign down to the next line. And students just kind of naturally, accidentally do this because you're working quickly or you're trying to be efficient. And so what I'm trying to do is get you to see that in essence, what is really happening here is you are multiplying -2 times the 9. And so if you look at things that way and you change it to plus right at the beginning, it's more natural for the way your brain works. And then you can see that this is really 5 times 81 plus negative 18, and then you won't have that issue of rewriting something incorrectly. Okay? So this example is one of the reasons why I changed the order of operations. Okay? So that's 16. Questions on any of the other ones? Go ahead.
22.
22, and Maria, what was your question?
18.
18? Okay. So let's look at 22 first. So 22, maybe I could have helped you out by explaining what you were supposed to do first. But I wanted to see what you could figure out on your own. So give me a thumbs up if you got number 22 correct. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, good. So here's the situation, and you're going to see this a lot this year. You're going to be given a mystery student's work, and your job is to analyze it and see if they did it right. This is a very important technique for teaching because basically what it's doing is making you the teacher. You learn a lot more being a teacher than you do being a student. So if I put you in the position of being a teacher, you will start to analyze things at a deeper level. So you are given this, 80 minus 1/3 times 15 squared. And then you're given the student's work. I would have preferred if the book had done the work going down this way. I think it would have made a little more sense if you saw each line going this way, but I can't control what the publisher does. So what it had was an equal sign, and the next thing it said was 80 minus 5 squared. And then it continues on, but here's where the mistake was. So let's see, I had 9 students who figured it out. How did this student get from this step, how did this student get from this step to this one? The 80 and the subtraction side stayed the same, so the only thing that changed was all this over here. How did they get from here to here? What did the student do? Got 3 people who know? 4 people, 6, 7 people. Savard?
He multiplied, he did 1/3 times 15.
That's right.
He did.
That's right. This student took the 1/3, multiplied it times the 15, and got 5. That was a mistake. You're supposed to do the exponent first. So you're supposed to do this whole thing before you do any of the other things. Okay? So it was 15 squared, it was supposed to be 225. Okay? So what should have happened was we should have done keep, change, change. So you know that that's really a negative 1/3. And you've got 80 plus negative 1/3 times 225. And then you work down from there. Okay? Did I answer your question? Does that make sense? So what was the sticking point for you? Was it you weren't sure what to
I
do?
wasn't sure what to
Okay, because the work went across? Was that why it was confusing?
do. Yeah,
Okay,
and then there was a lot of numbers, and it was just like, whoa.
okay.
I can't function with all of it.
Okay, so in the future, you should raise your hand and I can easily, in 30 seconds, help you see what you're supposed to see, and then you can work through it yourself, okay? Good. Any follow-up questions on 22? And then Maria, you said number 18?
Yeah.
Okay, so if everyone will look at their number 18. And 18 is a question similar to, that's not the one I was thinking of. 18 is 42 divided by n plus n. Is that the question you did?
Oh, okay. Yeah.
You did the wrong one?
Yeah.
Which one did you do?
No, I didn't put the plus n. I looked at it quickly.
Oh, you just did 42 over n? Okay. So that's why I do that. I always ask, is that the same question that you did? Because I want to make sure you didn't just do a writing error. Okay? Does anyone else need number 18? Good. Excellent job. Okay? Any questions about anything going on? Number 21. Okay? So number 21. Let me back this up. So, you were given 4d squared over d plus 1. Is that the question you did? And d was equal to 3. Is that the number you used? So we're supposed to plug in the number. So we get 4 times 3 squared over 3 plus 1. And here's the case with fraction bar. And I did it quickly towards the end of the lesson, but what I told you was with a fraction bar, you simplify the whole top, simplify the whole bottom, and then you divide them. So what'd you do first?
Well, now I know what I did wrong. Instead of addition, I did multiplication
On the bottom, so you accidentally did the wrong operation right there? Good, so you already found your mistake. Does anyone else need to see 21 continued on? Good. Okay, we're doing well. For the last time, you are going to draw a line across your paper. So everyone draw a line, dividing your paper for the final time, and then write the word homework or write a big HW. I don't care either way, as long as it's easy for me to see. We want to make sure we avoid foolish little mistakes, so when you copy things like homework, make sure you copy it accurately and with the correct numbers so you don't do the wrong assignment. So first, you are going to do page 5 in your textbook at home. Page 5, numbers 26 through 42, the even questions only. Then on page 10, you're going to do 4 through 30 even, and number 36. That seems like a lot, but it's really not. It's a total of 24 questions. Please write down that there are 24 questions. I want you to write 24, and if you want to write a Q, write a Q. If you want to write the word questions, write questions. There are 24 questions on the assignment. We're going to need that information tomorrow. And then you're going to have a quiz. Let me think about this. Next Monday or Wednesday. Monday. And it's going to be on formulas.